Hi, this is Huda Zenhom from Physics 2211, Section M. This is the third lab of the semester, known as the black hole. The purpose of this lab is to generate a unique star trajectory using your own email, which creates a dataset. Then we find the net force on the star for all the points in the dataset and estimate the mass of the black hole. This is done using the coding program GlowScript. Then we connect the data to relevant concepts and formulae that we are about to discuss. So, some key concepts that we want to know are Newton's second law, the momentum principle, the law of gravitation, and parallel and perpendicular net forces. As we can see here, the net force can be broken up into its parallel and perpendicular components, and each have their own formula, which we'll be using later. Here, we're going to use the law of gravitation in order to find the mass of the black hole. So, before we get started with coding, we have to set initial conditions. We have the gravitational constant, which has its universal value, the mass of the star, which is 2 times 10 to the 30, which is given, and delta t equals 86,400, the time interval, which represents seconds in a day, and we just start with time equals 0 for our initial. So our calculations using Newton's second law are going through this while loop. We set V initial and V final from the data set, and P initial, P final, the momentum, using the formula mass times velocity. And then we have delta V and delta P, which subtract the final we have the final minus initial. And dp dt is change in momentum over change in time. And Newton's second law comes into play here because we know that Fnet is equal to dp dt using the law. Finally, we have the parallel and perpendicular components using the formulas that we discussed earlier. The mass of the black hole is calculated by rearranging the law of gravitation formula to find the mass of the whole. And we see here that we have Fnet times r squared over g times the mass of the star. Then we print this into our output for our final mass that we get. So when we run the computational model, we have 3 arrows and we can see the motion, the circular motion. The orange arrow represents Fnet, the blue one represents the perpendicular force, and purple represents the parallel force. Then we have the final mass that we get, 2.23 times 10 to the 34, a very large value. And we have Fnet, Fnet parallel, and Fnet perpendicular as well. What does it mean? How are the net force and its parallel and perpendicular components different from the rate of change of momentum and its parallel and perpendicular components? Mathematically, these are equivalent. However, we can calculate the change in momentum, the rate of change in momentum, using the positions gathered over time and velocity. However, we can only calculate the net force using the mass of the black hole. What if? What if the black hole was replaced with a new one, in which the motion of the observed star remains unchanged, and is affected only by the gravitational force of the new black hole? Could you tell the difference? If motion remains the same, that means that the force and mass of the black hole remain the same, meaning the difference between the black holes is unnoticeable. We know this using this formula, force equals mass times acceleration, because motion, if it remains the same, that means acceleration stays the same, meaning that the force and mass also are unchanged. Thank you and have a great day.